Sean, and good morning, good afternoon, or good evening from wherever you may hail from. Today I'm going to talk about the cloud native 5G core. Um, there's three basic discussion tracks I want to walk you guys through. I want to talk a little bit about cellular evolution. We'll put some context to why we led ourselves to a 5G native um, cloud core. I want to talk about what are the benefits of taking this type of architectural approach, and then try to walk you through some of the practical challenges that we've seen as this phased introduction of cloud native has taken root within telco ecosystems. So let's talk first about how focus has shifted in mobile network generations. I've been through the full gauntlet of 2G to 3G to 4G to 5G. I like to look at the different eras in terms of the business models, and you can kind of define a business model by the value that's created, how the value is delivered, what value is captured, and what is the basis of competition. So if you go in the Wayback Machine to 2001, was the launch of 3G, there was definitely a view as to what kind of business incentive was going to drive it. In 2001, we knew that over the course of 5 years, at least as we forecast forward and historically has become fact, there was about 100 million or so subscribers that had yet to be acquired into the cellular world. And we just started to see the evidence of feature phones. Texts were kind of the roaring 20s, and people were peaking at 35 texts per month, if you can believe that. A lot of what was delivered in terms of value was through this feature phone, and you were being sold data plans, invoice plans. Competition was all about consumer subscriptions. And you move into LTE, and it's around 2009. Some interesting things have happened since. The feature phone had been subsumed by the smartphone. We had the availability of the Apple iPhone. And at this point, when you look at smartphone penetration, specifically in the North American market, you had somewhere close around 15% or so. And we still had about another 5 million or 50 million rather or so subscribers that had yet to be acquired into the cellular ecosystem within North America. So clearly this was a new era, that there was a definite business case in terms of where new revenue was going to come from. Value was being captured through upselling on data plans. We had consumer subscriptions that still that core basis of competition. But then you move to 2019, which was officially the launch of 5G within North America. And the hallmarks of what the economy should look like from a cellular perspective is less clear. We're pretty saturated, as it turns out, when it comes to acquiring new subscribers into the ecosystem. We're somewhere around 98, 95% penetrated in terms of smartphones. So there's not a lot of distance yet to go there. And so the question is what is going to be the business incentive of 5G? And when we look at them, it doesn't seem likely that consumer is really going to drive the tail of the tape as it relates to 5G. There's just not a lot more yardage yet to go in terms of acquiring. Whoever you want to acquire, you've already acquired. What we're seeing now is effectively churn management. So in some cases, operators are adopting 5G because you just have to be competitive. Some of them are looking at fixed wireless access. There was some dreams about potentially we could, charge a premium for 5G speeds. We saw some experiments with that in the market, but as the competition started to rage, those became discounted, and now we're about net even with 4G. So really, the opportunity for revenue expansion in 5G, where we had seen $5 increases in ARPU pretty steadily across prior generations, suddenly comes to an arresting halt in 5G. So, the big question on everybody's mind is, what is it going to be? And the answer seems to come as an enterprise revolution, that 5G is going to address digital transformation in a fundamental way that 3G and LTE were unable to serve. And the capabilities that are being delivered in order to do that are based on things like the multi-tenant mobile network. The ability now to morph that 5G network to allow it to be configured in a way that is equivalent to the way an enterprise would configure their local LAN. They can optimize it for the services that they want to run on and do that economically. They can couple that with a whole host of different edge compute appliances. They can start to really collect a new series of coverage solutions like private mobility around that. And they can start to enjoy an economy that very much looks like what we were able to enjoy when compute went into a multi-tenant type of economy. So what happens now is that we're seeing the value shift to this multi-tenancy capability. It's getting delivered not through a smartphone, but through edge computing. The capture from a value perspective is around these network slices, and the competition, the basis of competition is moving now towards these enterprise applications. So in an era where this is now the new basis of competition, that enterprise is now going to deliver on revenue expansion, the question is what's the right architecture? Should the architecture follow in the vein of what we had with 3G and LTE? And clearly there's going to be some dislocation of that architecture because you're trying to meet a new set of business drivers. So I need a new technical architecture to drive that level of transformation. So the cloud native 5G core is going to anchor this telecom digital transformation so that it can now be renewed into an enterprise wellspring of revenue. Now, what are the different things that we require once we start to shift the focus towards enterprise? Well, we need multi-tenancy. We need to be able to scale elastically. There's a whole host of different types of transactions that can now be realized in the 5G network. You can have many users at high bandwidth where you might have the same amount of resources for control and data plane, or you may have a high amount of endpoints that are connected to devices or sensor fields. Those sensor fields have very narrow bandwidth needs, so the data plane characteristics are less, but it has high control plane requirements. And so that different level of ratio between how I allocate my resources needs to be governed in a way that's very elastic. Similarly, when we took a look at feature agility, we're leveraging some of the capabilities that come inherent when you move to a microservices-based architecture and you have automated build pipelines that allow me to very rapidly shift, really the new features, new capabilities within the network. And why do you need that? A traditional cellular network tends to hone to an objective where I'm trying to reduce for deviation. I've got a lot of mission critical activity on this stuff. I don't want it to change fundamentally because it comes at a huge cost. When you're on the enterprise side of the equation, you need new features. You need that feature velocity so that a particular enterprise can remain competitive, given the degree to which it relies on its network for competitive needs. So that feature agility becomes very important. Being able to deliver things through a container-based microservices architecture and leveraging modern tools like CI/CD so that I can do canary-like deployments, red-green deployments. These types of rollout options suddenly become very relevant in an enterprise versus mass market consumer world. And finally, in order to provide that coverage capability, we need to dramatically lower the cost to operate. So when you're covering an enterprise and you're managing all those different types of configurations that are associated with this enterprise, I need to be able to scale the operations. And so that's going to come on the back of automation capabilities that are delivered through things like Kubernetes that brings with it things like service registries and resource discovery. Those basic capabilities are now being leveraged in order to drive enormous automation that the IT world has enjoyed for many years, but the operator world has not. Now, what we're actually discussing is one of the big barriers and hurdles towards this transformation of the 5G cloud native principles into telecom. Because when you start to play around with the operating model of a telecom network, you're dealing with the headline of what a service provider is. And one of the words that we use for service providers is that they're operators, and that's their identity. When you're going in and you're shifting what the operations model looks like, you have to be very careful about how that gets integrated. So what are some of the challenges? We've seen the benefits, we've seen kind of what the drivers of those benefits are, but what are some of the challenges? And the problem here is that cloud native principles came from a very particular architecture. And it was to be able to provide as a service for compute. And the architecture that's used from a hyperscaler perspective, whether it's Google or Amazon or Azure, is that they pool all their computing at a centralized location. And there's certain efficiencies that come as a result of that. When you're in a data center and one of your compute instances fail, there is an abundant amount of pooled compute in that same location that can take over whatever service that is there. When you move to a topology where it's less about the centralized capability, but more about the last mile capability, this edge to core set of compute appliances that stretch across the network of a telecom operator, you've got a different issue. You're trading off the pooling capability with this distributed capability. And that distribution tends not to favor all the cloud native types of applications that are out there. For instance, if something fails at the edge of your network, there might not be another compute instance that can easily take over. So that mean time to repair becomes very different, and it starts to kind of create some friction relative to that cloud native model. And so we talk about this in terms of a conflict between the last mile and first mile, and how do you kind of fit that architecture in there so that it works. So what are some of the problems that we have? We talk first on ecosystem standardization. So beyond, an application vehicle where a developer wants to launch something in Amazon, he has a set of standardized tooling, a set of deployment methodologies, and it's a rinse and repeat. Once you've got that underlying standardized harness and you've got the scope of capabilities that are required to deliver that application, it becomes a consistent way to do the deployment. When you're in a service provider environment, it's a silo of clouds, but there's not a lot of standardization right now in terms of what that underlying cloud infrastructure should be. And so your ability to use a labor pool that is focused and understands a particular operating model relative to a telco cloud is less resilient of the way that it is, for instance, with the public cloud. So that's something that we started to confront early on with network function virtualization, which is really kind of a precursor here to cloud native technologies, where we basically just had many different clouds that had different life cycles associated with it. We didn't get that consistency of operation that allows us to start to drive and reduce cost, apply standardized orchestration, and leverage that automation capability. So ecosystem standardization is incredibly important. We're not there yet. Edge distribution. So I talked a little bit about this whole notion of this distribution versus pooling. And so this opportunity now to do elegant failover by calling an API and bringing in a new compute instance is less really credible when you're at the edge. You might not really have a whole fleet of compute that's sitting at your cell site. So you're going to have more limited compute, and your ability to do failover now might need to rely on tried and true techniques like 1+1 equipment sparing and other fail in place measures, very different from the cloud native principles. A big issue here is this notion of stateful versus stateless. Stateless lets you scale out horizontally and avoid the old vertical scaling techniques that were used in telecom in years gone by. But when you're at the edge, this notion of stateless is just less relevant. You have to persist locally. It's very difficult to persist all the way back to the cloud, especially if that's going to increase the latency of a particular application. So we've got to rethink that, and there needs to be some thought around how do we create an available system, leveraging cloud native principles, but fitting into the realities of the telecom model. And the third is really around this notion of transformation migration. None of this stuff is going to happen in one big bang. You need to have more of a phased approach. It's very similar to what we've seen with NFV, where initially it was a lift and shift of existing proprietary applications into a virtual machine. Again, no standardization on life cycle. We didn't really gain in terms of deployment automation in that environment. And so for the most part, the NFV transformation underwhelmed. We've now got this transient really phase where we're leveraging virtual machines as well as containers. You've got this dual environment that is increasing the cost of operations, because now I have to have two separate modes of operations to support in order to maintain this cloud-based architecture. Really where we want to get to is an approach where we can leverage cloud native functions and not have to worry about a lot of these legacy or inherited applications that require refactoring in order to be deployed. And so that creates a bit of a fault line in terms of, can you now get all of the benefits that we've talked about in terms of cloud native delivered if you're only doing it in half measures? And the answer is really not. You really need to have an approach where you can elegantly move and practically move to a cloud native architecture. All right, well, those are kind of some of the challenges that we've seen, some of the benefits, some of the drivers. At that point, I've kind of finalized my prepared content. And so Sean, I'll hand it over to you maybe to help moderate on the questions.
Yeah, Vish, I think we have time for one question here. Unfortunately, we've got a good one here from US Cellular. When we think about the move with 5G to hybrid cloud operating models, how do you see the cost savings the operator realizes trickle down to the consumer segment?
Yeah, so how are we getting the cost savings of operating your network through hybrid cloud models so that lowering the cost to deliver bits to an end customer? And I think a lot of that's going to have to be based on what kind of economic models the service provider are going to pursue. There are some service providers, for instance, who are looking at models where they sit behind applications and they have a more indirect relationship with consumers. So think of something like cloud gaming, where you might have edge compute rendering, interesting, highly advanced and sophisticated games through a large pool of DSPs, and allowing the consumer to use a very low-cost device to be able to actually participate and engage in that gaming experience. Potentially, that consumer is only going to pay the gaming provider as opposed to the service provider. The service provider provides connectivity and the hosting capabilities, and accrue their revenue through the gaming provider. A very indirect model. It resembles, if people can think back to the beginning of Amazon Fire and the Fire tablets, where it was effectively a connection that was subsidized by Sprint that allowed you to read your Kindle services, all the different books that you could buy off of Amazon. That was a similar model where the operator kind of sat behind it and was able to participate in a revenue share of someone enjoying an application. And so, that could be one model. Another model may be, a tiered type of capability where there's resource restrictions based on what kind of application a user wants, and they could have that dynamically switched and maintained, and therefore you get a tiered set of revenue from a particular consumer. That's another model that some carriers have been looking at and experimenting with, especially in an era where I can have all these different types of quality of service associated with this multi-tenant 5G network. So again, that might be a different way where you discount very heavily on the low-end services and you put a premium on the high-end services, and dynamically behind you have caps that allow you to rate limit to how much a particular consumer wants to spend in a given amount of time. So all of those things are the monetization models that we could see. And so it's really highly dependent on how those work relative to how those savings are going to be delivered.
Excellent. Well, Vish, I really appreciate you taking the time to share your perspective and engage with our audience today. And for everybody watching, next up, we're going to talk AI ML for network automation. And please make time to visit our roundtables later in the afternoon. Thank you again, Vish.
Thanks, Sean.